Okay, so let's prove the tangent circuit theorem. So basically it's an if and only if. So I'm going to write this direction first. I'm going to say, so I'm going to draw a picture. I'm going to say a line is tangent to a circle. So I have that it's tangent. That means that it hits at one point. So here's my line L, and then here's my circle. What I want to prove is that then there's a radius, the radius from the center to the point of tangency, that point right there. I want to prove that that's going to form a right angle with the line, or that it's perpendicular to the line. So the way we do this is we say, well, if I know it's tangent, then I want to show, that it's the shortest distance. There we go. Good. Okay, so I'm leveraging the fact that if this line from this point to this line, right, is the shortest distance, then we know that it's perpendicular. Okay, that's an if and only if statement. So the shortest distance from a point to a line is perpendicular to the line, and if it's perpendicular, then it's the shortest distance. So here I'm gonna say let's label some points. Let's say A, B, L. So this is circle A, and I'm gonna say, let's start off with what we're given. We're given the fact that we have that line L. Line L is tangent to circle A. That means that there's only one point that L and circle A share. So B. That's weird. Point B. Yep, what's happening here? Did this thing turn off? Yep. Nope, it didn't turn off. Not completely. What's going on? There we go. Okay, so point B is the only point on L and circle A. Since it's the only point on L and circle A, we know any other point on L, therefore any other point on L lies on, let's say, the exterior or outside of circle A. And therefore, so any other point, say C, right? Then that means that if C is over here, it lies on the outside, and we have, and CA, the distance from C to A, is greater than the distance from B to A for any C. So BA is shortest segment from A to L. And then we know from this fact that it's the shortest segment from A to L, that then therefore it must be perpendicular. That's the final statement. Then BA is perpendicular to L from our previous theorem. That's one direction. Now the other direction that we have here is going to be that if it's perpendicular, so I'm just going to draw this as a right angle, I want to show that then it's tangent. And in this case, I think I need to do a proof by contradiction. Assume that it hits more than once, then yeah, okay. So if it's perpendicular, so I have that BA is perpendicular to L. Therefore, right away, right, we know from our theorem that BA is shortest segment from A to L. Now, we assume that L is not tangent. Now, off of your assumption, there exists some point C on L and circle A. And with that, so let's do a little drawing over here. So let's get this over here. Then let's bring it up and let's go. Okay, so let's have our drawing right here. So I have A, right? And then this is line L. This is a point, this is a point, this is B. This is C, right? And essentially we're assuming that it's not tangent. Now, this line, we know, since it's perpendicular, that it's the shortest distance, and it's a right angle. Now, if I draw the line from A to C, we should see that AC is the hypotenuse in this right triangle. But also, since, right, CA and BA are both radii, we have that their lengths are equal. So we have CA is equal to BA. But since CA is the hypotenuse of right triangle ABC, right, because this is a 90-degree angle, you know that, is hypotenuse of triangle ABC, we have that CA is greater than BA. And this is a contradiction. And you could draw your contradiction by the two arrows facing one another. The assumption is false. And we have our conclusion. You should always write out your conclusion. I'm deliberately doing that. I mean, like, it's typical to actually end at the contradiction in a lot of books I've seen, but assumption is false, and L is tangent. Right, just to remember what you're trying to prove to circle A. And then you're done. This is your proof in both directions. Not too bad.